Hi, everyone.
Hi.
Welcome back. We're going to start today with a number talk, and today's number talk is a true or false. So when we have true or false number talks, we are asking you to look at an equation and decide using a strategy if the equation is true, if it's correct, or if it's false, if it's incorrect. So right now we have 23 minus 5 is the same as 26 minus 5 minus 3. So right now you can pause the video and use a whiteboard or a paper and pencil to decide and show your work if this equation is true or false. So make sure you use a strategy that will help you decide if this equation is true or false. And teachers, when you are ready, just put a thumb up so that I know you are ready to share your ideas. All right, Miss T is ready. I'm going to wait for Miss Rosales so that we can have two examples of how this is true or false. Maybe we can come up with a third one together. All right. Miss T, since you were done first, do you want to start by sharing your strategy or how you know if this is true or false?
Yeah, so I wrote the equation just like you wrote it, and I did 23 minus 5 equals 26 minus 5 minus 3. And I know with the equal sign that whatever's on this side has to be the same as whatever's on this side. And so I noticed that there was a minus 5 here and a minus 5 here. So I actually took it as if they're the same, so I kind of removed it from the equation because I know if it's minus 5 and minus 5, they're the same. So I dropped down the rest of the numbers, which is 23 equals 26 minus 3. And I know 26 minus 3 is 23. So 23 is the same as 23. So that must be true.
Interesting. And I like that you grouped that minus 5 with the 5, the subtraction symbol with the 5, because that show they're together, right? It's minus 5 with the unit. So I wrote here that so far you took out that minus 5 from both sides of the equation, and then you put 23 is equal to 26 minus 3. And you got that 23 is equal or the same as 23. So the answer or the equation is true. Beautiful. Thank you, Miss T. And Miss Rosales, now it's your turn to share your findings.
So it's funny how our brains work. Great minds think alike. I also went ahead and noticed that whatever is on one side is the same on the other. And I took away 5 and took away 5 from both sides, and it's not that important. So because there's a minus 5 here and a minus 5 here, I ignored that. And then I did a tens and ones visual for the 23, 10, 20, and then counted up to 23. And then from here, I took my 26 and took away the last remaining 3. So you can see 20 and 6 ones. And then I dropped or crossed out 3. And so really what I have here is 23 is equal to 26 minus 3, and 23 is the same as 23. Now, if I really want to go back and solve this by taking away 5 from both sides, I can also show that apart from 23 is equal to 23, 18 is equal to 18.
Ooh, okay. So since we talked about that, let's use that strategy together and let's find out if we have friends at home that don't take that minus 5 out, what could they do instead? So if we have each equation, say we have, for example, the equation up here. Thank you, Ms. Rosales, for sharing your beautiful strategy. And I appreciate the visual because I'm a visual learner, so that helps me really focus on how you got the answer. So some of us need visuals and some of us are like Ms. T, where we can do it in our head quickly and have that fluency. So right now I want us to just look at the equation. If we have 23 minus 5 and 26 minus 5 minus 3, what's another way we can show that this equation is true by subtracting both sides of the equation? So I'm going to put it here, and this is our work together. So we have 23 minus 5 is the same as 26 minus 5 minus 3. So what would be the first thing we can do? Ms. Rosales.
We look at the minuend and draw the minuend. In this case, 23 on our first set.
23. And how should we draw that? That we can draw the picture, we can do tens and ones. What would be the most efficient strategy?
Ooh, Ms. T?
Well, I actually did counting back.
Oh, okay.
So I put 23 in my head and I counted back because I could hold 5 numbers in my head. So I went backwards 22, 23, 22, 21, 20, 19, and then I ended at 18.
I love it. We haven't really used this strategy recently, so it's a great refresher. Sometimes we want to use strategies that we have in the past just to remind ourselves and just to have a different strategy to use. So we have 23 and then our thinking bubble.
Yeah, and I learned this strategy from Miss Yakimowicz. So I'm so glad she taught it to me because now I can count backwards.
23. So we have 5, right? Because we're subtracting we're subtracting 5 numbers. So 1, 2, 3, 4, and then 5. And so then we go 23, 22, because we're counting back. 21. I'm sorry, my numbers are a little sloppy. It's hard to.
Good.
Oh, 19.
Looks great.
And then 18. So our last number where we stopped was 18. So we're going to write that in our number sentence. I'm going to put it on the bottom right here. 18 is the same as, and let's check the other part of our number sentence. So we started with the left side of our number sentence, and now let's look at our right side. So how can we solve this? We have 26 minus 5 minus 3. So one question, teachers, is this possible? Can we subtract more than 2 numbers?
Yes.
Yes? How do we know?
Because so long as the minuend is larger, you can continue to subtract on.
Okay. So what could we do? What strategy can we use this time, Ms. Rosales? Since Ms. T gave us a strategy for the left side of the equation, what strategy should we use for the right side?
So I'm looking specifically at these numbers right here, and my thought process is that I could go tens and ones because I am comfortable with that, but I could also do a number line and hop backwards. But I know that Ms. T has brought up friendly numbers before, so I'm gonna bring that up right now. So 5 and 3, we know that when we combine these, it makes 8. And we have 26 here. So if this is 8, can I regroup that in a different way so that I can subtract here? Sure. 6 and 2. So then if I have 26 and I take 6 away, can I do that in my head? Sure. 26 takes 6 away is going to give me back 20. Can I take 2 from there? Sure. Let's count backwards. 20, 19, 18. So my final answer is 18.
Oh, interesting. Thank you, Ms. Rosales. The first thing
I had a question.
Yeah.
Ms. Rosales, why would we add 5 and 3 when it says subtract?
Good question. So we have here, we're going to take 5 from here, and we're going to take an additional 3. So when we just look at what we're trying to take away, I know I'm going to take away 5 and 3 more. So I'm going to combine how many in all I'm going to take away.
Mm.
Does that make sense, or would you like a
Oh.
clearer picture?
So what I hear you saying is that it's like taking away 5 and then taking away 3 more. So if you think about the total that you've taken away, you're adding the total that you've taken away from the group.
Yes.
That's a great clarifying question, Miss T, because that's the same idea I was thinking about. When I saw this problem, I thought we were going to do 5 minus 3 and then have 2. And so I was a little confused, but now I understand the process. So thank you, Miss T and Miss Rosales, for sharing that with me. So then we had 26 and we took away the 6 that we have here, and it got us to 20. And then we had 20 minus the 2 when we decomposed the 8, and it gave us 18. So 18 is the same as 18. So here we have 3 different ways we can figure out if the number sentence is true or false. And we found out that the number sentence is true. So friends at home, I want you to think of another way we can figure out whether this equation is true or false. We know it's true, but there are other strategies we can use to show our thinking. So please please put your comments in the box below. Or you can upload a picture of your thinking, your math thinking and strategies to your Seesaw account. And we love to see all of your math work. So continue to share that with us and keep up the great work. We'll see you soon.
Don't forget to subscribe.
Bye.